All right, guys, I had a quick question on the YouTube, Bane Racing YouTube channel. Here it is. So basically he's asking where the confusion is, or there seems to be some confusion with a minimal cross-sectional area dynamic calculation of 690 feet and our guideline as far as turbo piping goes. These are two very different areas, and one's a dynamic measurement of peak velocity, the other one's an average. So let's hit the whiteboard and I'll break it down. All right, where the confusion is we're comparing a dynamic calculation of our MCA, which is our minimal cross-sectional area. So that's the smallest part in the primary induction. It'll be the smallest CSA that we use to calculate over RPM and our cubic capacity to see what our peak velocity is. So if we have a certain engine, we punch the numbers in and it comes up with 750, that minimal cross-sectional area is too small. That's what we're using an MCA limitation for. And even with the twin cams, I like them actually lower than this, depending on the cylinder head and where the MCA is. And I don't like as much variation between maximum CSA of the port and minimal cross-sectional area of the port. But what this is a single time dynamic event that we're measuring, and it roughly peaks at mid-bore. Obviously we get delay as we increase RPM. This wave will move and we'll have positive pressure, so positive velocity and pressure or inertia landing at the back of the valve, and this is what can also cause valve float. But that is one single valve event, and they happen 70, 80 times a second depending on the RPM, and that's the curve. And if we do it right, so opposite to pressure, this is our atmospheric pressure, it drops and then comes back up as our velocity increases. And if we do it right, we actually start with a positive wave if our third harmonic wave event lands as the valves open. So that's a whole nother video, but that is a dynamic measurement. We're not actually measuring on the flow bench, but average velocity that you'll see with pipes and all that sort of stuff, even though we're still calculating an average number, if you test a cylinder head, even the cylinder head's average velocity is going to be about 280 to 300 feet per second. Again, some are more, some are less, but depends what you're trying to achieve, and depends on how big the port is relative to the MCA. So we've got to look at average cross-sectional area of the cylinder head to understand that better. But yeah, that's basically the difference. One's a dynamic measurement calculation, not a measurement, sorry, and the other one is also a measurement but of an average, and we can also measure it on a flow bench in what we call a steady state flow, not a timed velocity event like it is in a minimal cross-sectional area calculation. Yeah, and as far as pipes go, yeah, the general rule is your tight radius stuff costs you about 1% of your peak numbers. So if you've got 4 real tight radius bends in your pipe work, it's going to cost you about 4% in your peak numbers. And that's because it creates tumble and separation inside the pipe. As it turns, it trips over itself because the floor speed is faster than the roof speed, and that starts to create all sorts of turbulent separation inside the pipe. That's why you'll see on really big competition drag stuff, even off the headers to the turbo, they try and keep it as straight as possible, and all the pipe work flows nice and slowly. So you're over that, I think it's 3D radius curves, so that way you don't get, you're not building that drag coefficient in your piping, so it's not creating a restriction. But yeah, hopefully that helps, guys. Cheers.